So after giving the circuit connection, we have designed the schematic based on the elements we have selected, PMOS and NMOS. We are trying to design an inverter here. So we can see the points, the nodes like supply and ground connected, then input and one output that is been operated here. We using a thin wire arrangement. Here you can see where the mouse is pointed, narrow wire arrangement, all the connections are made. Once the connections are made, we need to check the schematic for this using the A to D analysis. So ADL analysis. Now going there, we are going to start the setup. First setup, go to stimuli, select all the options we have operated. Let us go to power supply first. First step we have to do is enable it. Next, what type of source we are using? DC. What is the range we are selecting for this? 1.8. And once we do this setup, don't say OK, just press apply. Then go for the next. Even if you press OK, no problem. We need to again enter into the stimuli part. This is only for a precaution. Then again select the ground, say it as enable, then say DC, then put it as 0. Apply it again. Now the chance comes for the input which we are selecting. Enable it and we can put it in bits or pulse. We are selecting a pulse here, and voltage we are starting with 0, and we are varying the voltage between two levels, high and low. We can put 1.8 at voltage 1 or voltage 2, no problem. Period we are selecting it as 20N. Then for each situation, delay we are considering as 1N, rise time is 1N, fall time is 1N. Then the distance between each cycle width will be considered as pulse width there, then 10N. Okay, apply these changes. Now if we don't have anything to make in the setup, say OK. So we have entered the setup arrangement. Now go for analysis. Choose what you want to arrange there. So we want transient analysis, and the stop time, let us put there it as 200N. So what all the values we have practiced in the lab, same values we are considering here, and we are asking it for a moderate design. Just say apply, then say OK. Then between what values you want to plot your graph. So after setup, after analysis, go to output, say to be plotted. Select on the design what are the things we have to plot, input versus output. Then again after this, go to your ADL. You can see what all the options we have selected for our operation. Now go for simulation and go for netlist operation, or you have a play symbol on your console itself, you can press it. So we need to wait for the plotted graph to appear on our screen. Right, generally we find this mix-up arrangement. Now many of us have practiced this, how to split it. Just click on this. Right, this is the way. So success, the inverter operation is appearing here. You want to change the color, you can happily change it as input in green color and output maybe in red color or a pink color, whatever suitable arrangement we like. So at each interval we are seeing less number of spike also. So if we have the connections clear while making the schematic itself, we can expect very less number of spikes that are being generated in this graph. So we don't see any ups and downs, everything is flat here. So it's a matter of practice how we connect the schematic using less number of nodes. If we have good connection using wires, we will see less split in the voltage. Right, we need to save this, plot the graph in our records and observations. Thank you for supporting this video. Right.